Welcome to my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmaburi. In this video lecture from upcoming semester, Thermoengineering 2, Unit 4, Cogeneration and Waste Heat Recovery System. As previously we have discussed about the Model 1, Cogeneration, Production of the Cogeneration, Model 2, topping cycles and the bottoming cycle, Model 3, that is applications of the cogeneration unit and what are the factors affecting from the cogeneration. From the Model 4, we have discussed about the waste heat recovery system. From that the cogeneration unit, how to recover the waste heat for useful application. From this slide, we have discussed about the waste heat recovery system. From that unit is from this figure you can see this waste heat recovery system for various large applications. From the, for example, from the thermal power plant or gas turbine power plant or whatever cogeneration unit. With this help of this, we have to recover the 100% waste flue gases for useful applications. These are all the sectors are used for the large power station for the combined cycle unit. For example, from the gas turbine unit, because of how high flue gases are circulated from that gas turbine, we have to recover with the help of that flue gases for useful application. And also from that bottoming cycles, cement industries or glass industries or iron ore industries or chemical industries or refinery process, because of more amount of flue gases are present on them, this type of unit. So with the help of that flue gases or 100%, we have to recover the flue gases for useful applications from that waste heat recovery devices. From that waste heat recovery unit, we have discussed about the list of contents, waste heat recovery, heat losses, quality and quantity, principles of heat recovery units, classification of waste heat recovery systems, commercial viable for the heat recovery devices, what are all the benefits to utilize for the waste heat recovery system, what are the development you need for the waste heat recovery system, how to use it for the commercially for the waste heat recovery devices, and finally it goes to the waste heat recovery boiler. After that, what are the heat exchangers are used for the waste heat recovery system, recuperators, regenerating, ceramic, regenerating and heat exchangers. After that, the thermal wheel and heat wheel, and also nowadays used for the various applications for the heat pipe for the heat exchange process. Finally goes to the economizer, feed water, heat pump, shell and tube heat exchanger, plate heat exchanger, run around coil, direct contact heat exchanger, advantages and the limitation of the waste heat recovery devices. As I earlier told about how to utilize the waste heat from the useful applications, these are all the important devices to utilize that heat exchanging process to get the useful energy for that sufficient for the waste heat recovery devices. From that introduction about the waste heat recovery system, is an energy recovered heat exchanger that transferred heat from the process of output at high temperature to another part of the process for some purposes, usually increase the efficiency of this. The waste heat recovery unit is a tool involved in the cogeneration. The waste heat may be extracted from the source such as hot flue gases from the diesel generator, steam from cooling towers, or even wastewater from the cooling process such as the steam cooling. The waste heat is heat which is generated in a process by a way of fuels, combustion or chemical reaction and then dumped into the environment, even though it could still be reused from some useful and economic purposes. The essential quality of the heat is not the amount but the rather is value. The strategy of how to recover this heat depends upon the import and the temperature of the waste heat gases, and economically it will be involved. The large quantity of the hot flue gases are generated by the boiler, kilns, ovens and furnace. If some of the waste heat could be recovered, a considerable amount of primary fuel could be saved. The energy lost in the waste gas cannot be fully recovered. However, much of the heat could be covered, lost, minimized, adopting the following measures. So as I told about you from the furnace is operating from particularly we have to tell about the examples of glass industries. We have to manufacture the glass with the help of the raw material for the silicon and the glass wool. with the help of that furnace to melted. After the product will be coming from the outside. After that we have to utilize the ore industries or glass industries or cement industries. We have to recover the flue gases for useful application. That unit is known as the waste heat recovery unit. So various losses are happen on the waste heat recovery unit, but we have to form from the quality waste heat recovery and the quantity waste heat recovery. From the heat losses happen on the quality. Depending upon the type of the process, waste heat can be rejected virtually at the temperature. After that, from the heat losses in the quantity, from that process, the heat recovery from the heat treatment from the furnace. If you using this furnace from the heat available is 2100 into 1.1 into 0.24. From this calculation, we get the from the available from the furnace is 4,31,827 kilocalorie per hour is available. By installing the rectifier, this heat can be recovered by the preheat the compression of the air. We get the fuel saving from if it goes through the waste heat recovery unit. We have to saving the fuel for 33%, 1% of the fuel reduction of the every 20 degrees Celsius reduction in the temperature of the flue gases. Next slide we have discussed about the principles of the heat recovery unit. Waste heat from the exhaust gas of the various process or even for the exhaust steam of the conditioning unit can be used to preheat the incoming gases. This is the one of the basic method to recover the waste heat. The many steel making plants use this process as an economic method increase the production of the plant and lower fuel demand. Because of from the steel manufacturing industries, we have to melt the raw material with the help of the high temperature. We have to using that recover the hot gases and the hot flue gases used for the useful application and also to reduce the power demand in that particular industries. Next slide we have discussed about the classification of waste heat recovery temperature ranges. From the heat flue gases, that is there in the high temperature, heat in the vapor stream, there is a heat losses in the cooling water. These are all the waste sources available and the quality. And also we have to using the waste heat temperature and the high temperature from the various sources for from the different types of furnace. There is a temperature is based on the nickel refining furnace. The temperature range is 1370. Aluminum refining furnaces 650 to 750. Zinc refining furnaces 760 to 1100. Copper refining furnaces 760. So these are all the furnaces. Already told about it. From the steel heating furnace we get the 925 degrees Celsius. Copper reverberatory furnace we get the flue gas temperature is 900 degrees Celsius. Open hearth furnace the temperature is 650 degrees Celsius. And also cement clean industries the temperature is 620. Glass melting furnace 1000 to 1550. Hydrogen plant the gas temperature is 650. So we have to, because of this furnace there is a high temperature will be estimated and omitted. So we have to with the help of the waste heat recovery system to utilize the heat from the furnace for useful applications. Next slide we have discussed about the classification of waste heat recovery system and the temperature ranges in the boilers. Steam boiler exhaust is 232, gas turbine exhaust 370 degrees Celsius, reciprocating engine 315 to 600 degrees Celsius. From the reciprocating exhaust turbocharged, then we get the temperature 230 degrees Celsius. Heat treating furnace we get the temperature 425. Drying and packing oven 230 degrees Celsius. And the crackers, catalytic crackers we get the from the refining process 425 degrees Celsius. And the pyrolysis process also 600 degrees Celsius. And we have to calculate the waste heat temperature, and from this table we have discussed about the temperature from the various sources. We have to process the steam condensate. The temperature is 55 degrees Celsius. Furnace door there is a temperature 32. Bearing 32 degrees Celsius. Welding machine 32 degrees Celsius. Injection molding machine 32 to 88 degrees Celsius. Annealing furnace 66 degrees Celsius to 230 degrees Celsius. Forming die 27 to 88 degrees Celsius. From air compressor 27 to 50 degrees Celsius. Pump 27 to 88 degrees Celsius. From the internal combustion engine from the inlet condition 66 to 120 degrees Celsius. After that, air conditioning and the refrigeration condenser 30 to 43 degrees Celsius. Liquid steel condenser 30 to 82 degrees Celsius. Hot process liquid 30 to 230 degrees Celsius. These are all the low temperature recovery unit from the process. Next slide, we have discussed about the classification of waste heat basis of equipment. These are all the very important devices to recover the waste heat. There are the many different commercial recovery units for the transferring of the energy for hot medium space to lower one. First one is a recuperator. Recuperators. This name is given to the different types of heat exchanger that the exhaust gases are passed through, consisting of metal tubes that carry the inlet gas and thus preheating the gas before entering the process. The heat wheel is an example which operates the same principle in the solar air conditioning unit. Next one is a regenerator. This is an industrial unit that reuses the same steam after processing. In this type of heat recovery, the heat is regenerated and reused in this process. Next one is the heat pipe exchanger. The heat pipes are one of the best thermal conductors. They have the ability to transfer heat 100 times more than the copper. Heat pipes are mainly known as the renewable energy technology as being used for the evacuated tube connectors. The heat pipes are mainly used in the space process of air heating in waste heat from the process being transferred to surrounding due to transfer mechanism. From the heat pipe is generally used for your computer also we have using the fan. There also we have using the heat pipe, but in the space technology very essential for the heat pipe because of the heat will be dissipated from that particular input with the help of that heat exchanger or heat pipe to exchange the heat from this process. Last one is a thermal wheel or rotary heat exchanger that consists of the circular honeycomb matrix of heat absorbing material which is slowly rotated between the supply and exhaust layer of the steam and the air handling system. Next one is the economizer. In this process, there is a boiler is used for to increase the. These are all the units or to increase the efficiency of the particular unit waste heat recovery system. Waste heat from the exhaust gas is passed along the recuperator that carries the inlet fluid from the boiler and thus decreases the thermal energy intake of the inlet fluid. The heat pumps are used for organic fluids that boil at a lower temperature, means that the energy could be regenerated from the waste fluids. Run around the coil comprises two or more multi-row filled tube coils are connected to each other by the pumped pipe cycle. Next slide, we have benefits of waste heat recovery system and the development of the waste heat recovery system. These are all the commercial waste heat recovery system is used for the waste heat recovery boiler, recuperators, regenerator, heat pipe exchanger, thermal wheel, economizer, heat pump, heat wheel, heat pipe, run around coil exchanger, thermocompressor, direct contact heat exchangers. So from this figure we have to detailing see about the waste heat recovery boiler. This is a combined cycle utilized for the HRSG. From here the gas will be flow from the hot flue gases recovered from the heat waste heat recovery unit. From here there is a different types of units are available. There is a low pressure, high pressure steam drum, low pressure steam drum, and the integral deaerator, low pressure vent balancer, black. So these are all the very important units to recover the hot flue gases for useful applications for here the HP evaporator, HP economizer, low pressure superheater, selective catalytic reductions, and the LP evaporator, deep preheater. From the waste heat recovery unit, we have to utilize the flue gases for useful application. Means these are all the devices for essential for that to processing the unit. We have to produce, for example, we have to produce the excess steam, that is the high pressure steam or low pressure steam. Means with the help of this waste heat recovery unit to produce the steam and use it for the useful application to rotate the steam turbine and to produce the more amount of electricity from the waste heat recovery boiler. So next slide we have discussed about the photography of the waste heat recovery boiler. There is a burner, superheater, evaporator, and economizer, and from the chimney. These are the waste heat recovery boilers are used for various applications. The specification of the waste heat boiler or the initial cost is 350 lakhs. If we have the new boiler efficiencies, we get 80%. We have the saving from that per annum for 160 lakhs per annum to entirely to reduce the pollution level. This type of boilers are used for application point of view. Thank you.